And welcome to lesson 915, the last lesson of chapter 9, where we are going to use the zoom factor, area factor, and volume factors in order to solve problems. So nothing new today in terms of lesson new content, just using what we talked about in lesson 914. Okay. So first off, the warm up, the review. In part A, you're finding the volume of a cylinder. So remember, you find the area of the base when you're dealing with volume, regardless of what shape it is. So in this case, your base is a circle. Therefore, you take pi times the radius squared. Be careful here. Notice I gave you the diameter, not the radius. And then once you have the area of the circle, then again, you're going to think about like you're filling this up. You're stacking circles on top of each other. So then you multiply by the height of 13. In part B, the right triangular prism. This is a prism that's kind of laid down on its back. So your bases are actually the front and the back. And you're stacking these right triangles from front to back rather than up and down. But again, same idea. If you're finding the volume, you find the area of the base. So you start with the area of this right triangle, 1/2 base times height, or base times height divided by 2. So you're going to have to find what this is. Notice over here that 5 is the length of your hypotenuse. That'll slide over here and be the length of the hypotenuse there as well. Once you find the area of the right triangle, then again, think about like stacking these from front to back. So we multiply by the height of 15. Okay. So here are the answers. You can kind of see the different answers that are here and take a look at those and see if that makes sense. Then I put this back in again to the lesson. This is just the idea that, remember, if you're talking about r squared, and r cubed, all that's saying is if you have your zoom factor, okay, remember that's comparing side lengths, or if you're talking about a circle, the radius, something that's just comparing dimensions. If you square the zoom factor, that'll give you your area factor. Okay, that's what this is saying right down here at the bottom. And remember, surface area is just an area. So if some shape is 3 times bigger, that means the surface area then will be 9 times bigger. Okay, and the r cubed then is your volume factor. Okay, it's the zoom factor cubed. So again, if the radius, let's say, is 3 times bigger, then that means the volume will actually be 27 times bigger because that's 3 cubed. Okay, so that's the main idea back from lesson 914. And here's exactly that explained. Okay, what is the zoom factor, area factor, and volume factor? And again, remember, if you're looking for perimeter, that's always the same as your zoom factor as well. But mainly we're focusing on how zoom factor is related to area and volume factor. Okay. This, by the way, if you would like to, remember on your last toolkit, we already added in most of this. I would go back and I would add in the last part, the zoom factor cubed equal to the volume factor, in the same box where we put the other two. Okay, I would add that stuff in. Here's a video kind of explaining zoom factors. It's a little bit different than the video I showed you in 914, and it's only a little more than 5 minutes long, so it's not too bad if you're struggling to just take a look at that. Here's an example talking about, again, using that idea of zoom factor and volume factor. If you notice, I'll let you kind of read through this, but when they talk about ratio of similarity, that's just another term for zoom factor. So if they're saying A to B, okay, that's just your zoom factor from one shape to the other. The ratio of areas then is just that zoom factor squared, and the ratio of volumes is that zoom factor cubed. Okay, so if you take a look up here, talks about the shipping peanuts in a packing box. They're sold in 3 boxes: small, medium, and large. Volume of the small one is 1,200 cubic inches. Dimensions of the medium box are twice the dimensions of the small box, so there's your zoom factor. And the large box has triple the dimensions of the small one, so there's a zoom factor as well. Okay, so you're trying to use the zoom factor then to find your volumes. So if you take a look, here's my zoom factor. Okay, from medium to small, it's a zoom factor of 2. Therefore, my volume factor, if you will, is going to end up being 8. Okay, so that's what they're saying down here. The volume of the medium box, that's what that M stands for, is 8 times the volume of the small box. okay, or 9,600 cubic units. Over here, same idea, but just using the large box. That's in a 3-to-1 ratio. It's 3 times bigger. Therefore, the volume would be 27 times bigger than the small box. Okay, and so again, here's that being explained. The volume of the large box is 27 times the volume of the small box, 1,200, for a total of 32,400. Okay, so that's how this is a good example of how we're going to use those volume factors, so we don't have to just recalculate everything when we do that. Then if you get into the practice problems for today, what I want you to notice on these first 3 problems is our ratio of similarity, or our zoom factor, is 1 to 3, okay, or 3 to 1 if you go from bigger to smaller. Okay, so if the edge of, when they say the edge of the larger prism is 30 units, they're talking about just a length, so that's kind of talking about zoom factor. And then when it says find the length of a corresponding edge, we're just talking about zoom factor in here using the zoom factor. Okay. Then we get to area, so now we're going to use that zoom factor from number 1, and we're going to go through and we're going to, or from up here from 3 to 1 zoom factor, we're going to use that with area, and then finally number 3, we're going to use volume factor. Okay. Then a little bit of review down here at the bottom for surface area of both a regular pentagonal prism and a cylinder. Remember, when you're finding surface area, biggest idea you need to remember is find the area of all the parts. So in this case, you've got the area of a pentagon. Remember, you got to break that into triangles. Find the area of one triangle, and in this case, we'd multiply by 5. You've got 2 pentagons, and then you'll have 5 rectangles that you have to find the area of. Add all those up, and you'll have your answer. Okay? Cylinder, remember you've got 2 circles. Okay? In this case, front and back. Pi times the radius squared gives you that. And then remember that the body of the cylinder is actually a rectangle, where it's the length of the rectangle is actually the circumference of your circle, okay, which you have a radius of 6. Remember, it's 2 pi times the radius, and then multiplied by the height, which is 14. Okay, and then add all those 3 parts up. Last one then, finding just the area of a regular hexagon that has a side length of 12, just giving you back to some review again of defining areas. Okay, and then here's all of the work, all of the answers. Make sure that you check everything so that you understand what's going on with all of this stuff. Okay, it's all there, and if you have questions, do not hesitate to email me, and we can get that taken care of. Okay, so that's lesson 915. I hope it makes some sense, and good luck with everything.